Hello everyone, my name is Sergey Jidlev, and today I'll be talking about the Ubuntu operating system. Now, something interesting in my research is that I found a lot of research to use Ubuntu and Linux interchangeably. So in the end, what I ended up deciding to do was to just research Linux instead, because Linux seems to have a lot more research, not research, but a lot more information and documentation about it out there. And using Ubuntu is being a distribution of Linux, I'm pretty sure that all this information should pertain to Ubuntu as well as Linux itself. So let's get started. Okay, so here's what I'm going to cover. I'm going to cover CPU scheduling, memory management, input-output, and the file system. So I'm going to cover all four choices that were offered in this final project. And if you look to your right, you can see that we have this wonderful image that I found on Wikipedia. It kind of summarizes the whole Linux kernel. It simplifies it, but it summarizes it, and I think in a wonderful way, where you have the memory management subsystem and how it deals with virtual memory. You have how you've got the paging page replacement and the page cache. You've got your I/O scheduler. I think this is a wonderful image that really you should take a moment to appreciate how well it summarizes what we've been learning and how the Linux kernel works. Okay, so CPU scheduling. Um, when Linux first came out, the CPU scheduler worked in ON time. That's the algorithm that it used. ON time is not very good. It's linear. If you've taken algorithms, you know it's kind of like okay. It's kind of like the middle ground. It's not exponential, but it's not logarithmic. And then later it went on to O1 time, and then the completely fair scheduler that I'll be talking about in a second. So yeah, O1 time linear. It became obsolete because of the because of JVM, because Java created a lot of processes, and then and then it just slowed down the system. So they need to come up with a different one. So they came up with one with O1 time. So O1 has two types of processes. It's got real-time processes and normal processes. So real-time are prioritized from 0 to 99. So they have a higher priority than normal processes. And they're always real. This means that real-time processes can become normal processes, and normal processes can become real-time. Now, for normal processes, there's two types, interactive and batch, and they take up priorities 100 to 139. So interactive is I/O, and it has a quick wake-up time, because if you've got a slow input time, then your system will feel sluggish. And then there's also batch. Batch just runs in the background, and and these two can switch between each other. So an interactive can become batch, and batch can become interactive. Okay, on to the next slide. So this is the algorithm that is the default algorithm for Ubuntu, and I'm pretty sure for Linux as well. So it's a completely fair scheduler. So it's CFS, which I'll be referring to it from now on, places new and old tasks into a red-black tree, and it does not reuse the old runtime, but rather assigns a new one. Unlike the constant time algorithm. This allows for sleeper fairness. Let me see if I have a slide about that. Okay, no I don't. Yeah, so this allows for sleeper fairness. For each task to get a fair share of the CPU time, no matter whether it is running or not. Now, how does this compare to round robin, for example? Well, in round robin, each process on the ready queue gets an equal share of the CPU time, while processes that aren't sleeping don't get any priority once they are ready. Right, so they get a specific time box that they go into, and that's their box. And if they're sleeping or not, they get a specific time box. In CFS, the processes sleeping get a build-up of credit. So once they wake up, they aren't blocked anymore. And I mean, once they wake up or aren't blocked anymore, they get more processing time. And that's what is referred to sleeper fairness. That means that the sleepers get priority because they're sleeping and weren't taking up CPU space, CPU time. Now, Ubuntu supports like a ton of different algorithms, like earliest deadline first, which gives the CPU time to the task with the highest priority. First in, first out, which is obvious, and round robin, which is a time boxed type of algorithm, and it supports many, many more. So now let's go on to memory management. So Ubuntu includes the implementation of virtual memory and demand paging, and memory allocation for kernel internal structures and user space programs. And one of the benefits of using Linux is the ability to customize almost everything, including the memory structure. Something interesting is that all processes share the same memory space. That means that all processes, including the operating system, share the same memory space, which leads into virtual memory. So for virtual memory, you need to know your total memory space, and therefore you use virtual memory. And it is, as you know, creating blocks of memory that logically start at 0, but are physically contiguous. This also means that you can move memory and swap it out to disk. Now, because you can create blocks, you are allowed to use compaction because it's all virtual memory, right? So you can just move stuff around and you can compact everything to combat fragmentation. And also the reason that it's virtual is the reason you're allowed to swap it out to disk is because it's virtual. And another nice thing is that once virtual memory is mapped, there is no overhead. And the hardware that does this is the memory management unit, which you will learn about if you haven't already in the computer architectures course. So what the memory management unit does is, in summary, handles the load and store instructions for the memory. Now, we also are allowed to have demand paging. Demand paging is when you have pages that haven't been used in a while, or haven't been referenced for a while, they are moved to disk. So you move them to disk, and moving from disk back to memory when they need to be referenced creates overhead. But the benefit of doing this is it allows for a larger memory space, because you can move stuff out of memory to create more memory for things that are being referenced constantly. Now, when you move something out of memory and it gets referenced, that is called a page fault, and that is the overhead. The other benefit is that processes can begin without having any pages in demand paging. And this is an example of the lazy loading technique. If you'd like to go more in depth into it, you can Google that and find that online. Okay. Now let's move on to input-output. So, input-output uses std-in, which is the standard input, std-out, the standard output, and std-error, which is the standard error. This std-in is keyboard by default, std-out is screen, and std-hour is also screen by default. Something interesting that I found out that I'll be going into later in file systems is whenever any program is executed, these three files are created. So these three files specifically, that's something interesting that I learned because turns out in Linux everything's a file. Okay, either way, one interesting thing that you have in Linux is input redirection, or input-output redirection, and actually standard error redirection as well. So by adding a greater than symbol, you can have one program's output read into a file instead of the screen terminal. You have to use this carefully because this command can overwrite. You can circumvent this by writing the specific character twice, and this will just add to the file that you want to write to. And then for input, you can use the less than symbol. So if you need to attach a file to an email, you just use that. And the last one is std error. So since some commands generate a lot of errors, you might want to redirect the error stream somewhere else in case you don't want cluttering up the terminal, or if you, for example, are a database administrator and you want to log errors, that's when you'd want to stream the standard error out to something else. And something interesting is you can actually stream it to both a file and the terminal at the same time. So if you want to both see an error and log it, you can do that as well by adding an ampersand sign, if I remember correctly. Now on to file systems. So Linux file systems comes from Unix, which is a predecessor to both Mac and Linux, and so basically every Linux distribution. The file system is case sensitive, and something interesting is, like I mentioned previously, is that everything's a file, including the keyboard, stdin, your printer, that's a file. Yeah, and the file system organizes files in a hierarchical tree, where the relationships are child and parent. Directories can contain other directories as well as regular files, which would be the leaves of the tree. The regular files would be the leaves of the tree. The file system on Ubuntu, unlike Windows, has just one main directory, which is root. And from there, all the other directories are accessible, if the user has the correct permissions, obviously. Let me see if I have more slides. Okay, yeah. So Linux uses a two-part software implementation to manage the file system. This means that the virtual file system provides a single set of commands for the kernel and for developers to access the file system, right? So we've got the kernel up here and the virtual file system here, and the different types of file systems that you can possibly have. You can have a ton more, but in this example, we have this, and that's the hardware. But yeah, so the virtual file system calls this a specific device driver to interface with the various types of file systems. The driver is the second part of the system, hence the two-part software implementation. And this means you can have different types of file systems all controlled from the kernel in Linux, and have the commands run on a bunch of different file systems without having to change the command that you're inputting. So you can control a bunch of different file systems with the same command without having to change it. And that's the end of my presentation. I hope you guys enjoyed it, and thank you for listening to me talk.